So welcome guys. We are going to actually be starting the course talking about the most fundamental component in electronics, resistors, right? And resistors belong to a component class we call passive electronic components. And passive components, unlike active ones, they don't introduce any energy into a circuit or amplifying signals. Instead, what they do is they store, they dissipate, or they consume energy. And another defined characteristic of passive components is that they are linear devices, meaning the behavior follows a predictable and a well-defined mathematical relationship. This linearity is kind of key to understanding and designing electronic circuits. So we see the resistor here, the schematic symbol of the resistor, as actually like a box with two wires at the end of it. Sometimes you'll see a squiggly line, but this kind of box, this schematic is kind of what we will use for the during this course. And the primary function of a resistor is to oppose or resist the flow of electrical current. And in practical applications, what we use them for is to actually limit the amount of current flowing through a circuit, ensuring that other components operate within a safe limit. So I kind of have that demonstrated here. And if we look at our circuit, we see that actual circuit here with a resistor, and we see that we have a positive supply coming in here. We have the resistor, we have an LED, and then it's going back out. And what this resistor is actually limiting the flow of current that will be going through the circuit. And resistors can be in various types. We have metal film, we have metal oxide, we have resistive. And the ones that we are accustomed with, they kind of look like this. Is kind of metal film or carbon film ones. That's the same type like that's in our circuit here. And we could also have ceramic types. Resistors come in all kind of shapes and sizes. We also have the surface mount resistors. And these surface mount resistors, typically have markings on them, and they kind of follow IEC or EIA standards. And if we look at that, we could see them in a real circuit. We usually see them marked with this R. You have this R kind of marked on it's resistors. And that's what they look like on actual circuit board. Now, we could spend all day talking about resistors, but what I really want to do is actually look at using them in circuit, see what resistors actually look like when you use them in circuit. So we have our resistor here, and what I'll actually do is we'll look at resistors in series. So when we put resistors in series, we actually connect the resistors one after the other. And what that does is it adds. So when you put resistors in series, we have a 1K and a 10K that add together. So we could actually examine that in practice. So remove our ground, right? We remove the LED. And if we put our 10K now in series with the 1K resistor, right? We put it like that, so it flows one after the other. We look at the LED, remember the long leg is going towards the positive side. And we actually connect the negative end, right? We see that it's much dimmer. See, we can barely the stick of this light. The LED barely glows compared to where it was before, right? It's much dimmer. And that's what series resistors does, is they add together. Now resistors, when you look at the schematics, you'll typically see K, or you'll see R, and this K is just the measurement for the unit of resistors which we measure in ohms. And the K in resistor stands for kilo ohms. You'll see K a lot. You'll also see M is for megohms, and if the resistance is under 1,000, we usually write a R after the number, right? So you'll see 220 R or 100 R or things like that. We could also look at resistors in parallel. Now, when you look at resistors in parallel, you'll think that at first glance, if you're not familiar, you'll think, well, okay, well, this resistance is in the circuit total is 20K. However, as counterintuitive as it seems, this circuit actually has less resistance than the 1K and the 10K resistors in series. Because, when you push resistors side by side like this, it's known as a parallel connection. And When circuit goes through in a parallel connection, the resulting resistance is actually R1 times R2 divided by R1 plus R2. So if we have two 10K resistors, and the resulting end resistance will be 10 times 10 divided by 10 plus 10, which is 100 divided by 20, which is 5. And it seems counterintuitive, but you can actually look at that. So what I'll actually do is I'll actually grab a second 10K resistor and remove this 1K here. We have 10. We'll put this 10K in circuit, right? And then we'll put the second 10K next to it, like that. So they are both connected in parallel to one another, right? And if we actually, connect the LED now, we see that it's actually a little brighter than it was with just the 1K alone, and that's because when we had the 10K and the 1K together, the total resistance was 11 kilo ohms, but this way it's only 5 kilo ohms. That's what I really want to talk to you about. So we look at some other stuff with resistors, but series and parallel is what we'll be using the majority of the time.